All right, let's look at this example of AC circuit where we have a resistor of 15 ohms, an inductor of 0.7 Henry connected in parallel to a 20 volt 50 hertz supply. We are expected to calculate the value of the current drawn from the circuit, the phase angle, and the impedance of the circuit. So I'll quickly jump into it now just to show us what it looks like. First of all, we are going to get the value for our inductance. Our inductance XL is given by this, so we can put in the value 2 pi times 50 multiplied by 0.7, and this should give us the value of 220 ohms. Okay, already we know the value for our R. So therefore, what is the value of the current drawn from the system? So with this, we can say that our IL, which is current drawn by the inductor. Sorry, I didn't get to draw the circuit diagram. Let me just draw that out. So it looks somewhat like this. We've seen that before. Then this is 230 volts, 50 hertz. This is 0.7 Henry, and this is 15. Also, we are asked to look for this current. So this is IL and this is IR. So IL here is just V all over XL, which is 230 all over 220. This should give us the value of 1.05, and up next we have to calculate the value of our IR, which of course is V over R, is 230 all over 15, and that should give us 15.3 amps. So since we have our values for IL and IR, we can easily compute for our I. And from the formulas we go from our Phasor graph, we agree that what is I squared which is the same thing as the root of 15.3 square plus 1.05 square, and that should give us 15.3. You can see that the value here is very small, so we see that most of the current is being taken by our resistor. Alright, up next we are asked to calculate the value for our phase angle. Phase angle is simply phi from the graph we drew the last time, and we said we can get that from the tan inverse of what? IL over IR. IL over IR. Remember, we had the graph that looks somewhat like this. This is VS, and this is I. This is IR. This is our angle. This one is IL. And we say we can get this angle by having what? Adjacent over hypotenuse, isn't it? Okay, so we saw the graph here. We can relate I and IR with cos, and we can relate IL and IR and IL with tan, where we say that what is what adjacent opposite over adjacent here where we have IL over IR. So straightforward, we can actually put the values that will give us tan inverse of what? Our IL is 1.05 divided by 15.3, and this should give us 3.93. Okay, so that is value for this. Finally, we are asked to look for the impedance of the circuit. It's easy to get the impedance of the circuit by simply substituting the value of current and voltage. So impedance is equal to V over I, which is the same thing as our V is 230 over I, which is 15.3. So this will give us 15 ohms. That will be it. We saw how we're able to get all our values straightforward. From this, we get our current values, get the overall current, get the angle, and can get the impedance from here.